All right, so for the start of chapter 4, we're going to be introducing what a quadratic function looks like. So we've got a couple different methods that we're going to use. The first thing we're going to do is graph by using a table, and then we're going to learn how to plot like the vertex and from the intercepts and things like that. So quadratic function, first of all, just to give you kind of the general setup, a standard form quadratic function looks like this. Okay, so we've got those three pieces right there. In a quadratic function, the highest term, the greatest exponent, is 2. So we've got 3 different pieces. This piece right here is the quadratic term. Okay, so the term, the coefficient, and the x squared together, we call that term the quadratic term. This piece right here we call the linear term. And so we're used to just seeing, if we cut that out, this looks just like a linear function that we're used to. So that piece is known as the linear term, and then the one that's just a free-floating number, not attached to a variable at all, that is known as the constant term. Okay, so we kind of defined all of these things right here. All right, so with the first example, we're going to kind of start out the way that we usually have with different types of functions, is we're just going to start picking x values and plugging them into the function and trying to get an idea of what this graph looks like. So here's our standard setup here. If we do from -2 to +2, that's usually a good setup, and we want to get enough values down that we can see what the shape looks like. So let's see how these look, and if we need to add more, we will. So the -2 gets plugged in to this function right here. So the 2x's that you have right here, you're going to replace first with the -2. So we have -2 squared plus 3 times -2 and then -1. So this is 4, minus 6 is -2. Minus 1 is -3. Okay, then plug in -1. So -1 squared plus 3 times -1 minus 1. This is 1 plus -3 is -2. And then minus 1 would be -3. Okay, plug in 0. So plugging in 0 for x, by the way, if you remember from last chapter, that's how we get our y-intercepts. So this is 0, this is 0, so -1 would be my y-intercepts. Plug in 1. This is 1, plus 3 is 4, minus 1 is 3, and then 2. Okay, 2 squared is 4. Plus 6 is 10, minus 1 is 9. Okay, so that'll give us a decent enough picture of what our graph is going to look like. So let's set up our coordinate system over here. We've got 1, 2, -1, -2. We need to be able to go at least as low as -3 and at least as high as 9. We're just going to keep extending this. Sorry, constant term. There we go. All right, so -2, our graph is at -3, so that would be this point right here. -1, we're actually also at -3. We'll talk about what that means in a second. 0 is at -1. When x is 1, our y value is 3. And then when x is 2, our y value is 9. So that's all the way up here. So it's looking pretty unbalanced. So let's plug in one more value. Let's plug in the -3 just to get the shape. So this is what I meant before when I said we'll plug in more if we need to. So -3 gets plugged in, we square it, plus 3 times -3, and then minus 1. So -3 squared is 9, plus -9 goes to 0, and then minus 1 would be -1. So that means I've got a point right here. So it's starting to look more balanced. So you can see that this would kind of scoop down, and then it would start to go back up. We know the shape of parabola is going to take on. So connect the dots. It's going to go a little bit lower here, come back and hit this point, and then finish off its U shape. So it'll look like that. All right, so something we're going to talk about on the next page that's super important. Every parabola has a point right down at the bottom here. It's called the vertex. In this graph, it's at the bottom. Parabolas could be flipped upside down, and it could be at the top. So on the next page, we're going to define kind of a bunch of key features about parabolas. The vertex is one of them. Okay, so the graph of a quadratic function, we've got a couple really important things that we're going to look at. So let me show you just kind of a generic sketch. So let's say our parabola looks like this. And we could graph just any generic parabola here. There's just a couple key features. So this point that I mentioned right here, that is known as the vertex. And then we have a line that's not actually part of the graph, but you could draw it down the middle like that. And that's a line of symmetry. If you guys remember symmetries from geometry, that means you could fold the line in half over that line of symmetry and it would look exactly the same. Okay, so two very, very important features here. So that point right there, that is known as the vertex. It's either the low point, which it is here, or if you flip it upside down, it would be the high point. And then this dotted line right here, this vertical line, is known as the axis of symmetry. Okay, so I'm going to teach you right now how you find the vertex and how you find the axis of symmetry. So again, let me write our generic function. So we've got f of x equals ax squared plus bx plus c. So to find the axis of symmetry, we've got a formula. Okay, so it's an x equals, because remember vertical lines are x equals lines. So the equation of the axis of symmetry is x equals, and then we take negative b over 2a. So that's a formula that you guys just kind of have to memorize. So b is whatever number is attached to the x, and then a is whatever number is attached to the x squared. So that formula will give us our axis of symmetry. To find the vertex, this is our x coordinate, and then we plug in x equals negative b over 2a to get the y coordinate. And then we'll have the ordered pair that represents our vertex. And then finally we want to get the y-intercepts. So the y-intercept, we plug in 0 for x, so it'd be a times 0 squared plus b times 0 plus c. So since you're plugging in 0 right here, those terms will just be 0. So your y-intercept is always just c, just whatever the constant is hanging on the end. Similar to y equals mx plus b. It's always just whatever the constant is. So vertex and axis of symmetry to plot points and graph a parabola. So I'm going to give you kind of a step-by-step here. So step 1 is we find the axis of symmetry and the vertex. Okay, and then we're going to plot those. And then the next thing, step 2, is we're going to find the y-intercepts and its reflection. So I'll explain what I mean by that. So find the y-intercept and its reflection. So for instance, like this would be the y-intercept right here on this graph. And since this is a line of symmetry, every point on the left is perfectly mirrored as a point on the right. And this distance is the exact same. So we're going to graph the y-intercept and then its mirror image on the other side of the axis of symmetry. All right, and then step 3 is pretty simple. You just connect the points with a smooth curve. Okay, so we're going to do one example here. So here's our equation. That is in standard form. It's backwards. So like this is the c, this is the bx, and then this is the a. If that freaks you out, by all means, write it back in order. It's totally fine. Make sure you keep the coefficients attached to each piece. So that's more of what we're used to. That's the form that I gave you on the previous page. So we're going to go through our steps. So find the axis of symmetry. So that formula works like this. We've got x equals negative b over 2a. So negative, and then remember b is whatever is attached to the x. So that would be negative 4. So this is going to be negative 4, and the double negative would make it positive, over, and then 2a. A is whatever is attached to the x squared, which technically here is a 1. I have some people that'll think it's 0. Be careful with that. So you plug that in here. So we have 4 over 2, and that's 2. So that's the equation of the axis of symmetry. The axis of symmetry is like x equals 2. That's a vertical line. We'll plot that first. And then for the vertex, you take this 2 and you plug it into your function. And then we get the y value. So plug 2 in, so we've got 2 minus 4 times 2 plus 2 squared. So 2 minus 8, that's negative 6, and then plus 4 would be negative 2. Okay, so our vertex is the point 2, negative 2. We found x by using this formula, and then we plugged it in to get the y value. All right, so we know the vertex is always going to be on the line, the axis of symmetry, so we just need to find out what the y value would be at that x value. And then the y-intercept, remember, is always just the constant that's free-floating, because if we plugged in 0 for x, these two terms would be gone. And so the y-intercept is just 2. So technically that's the point 0, 2. All right, so table of values, we're not really going to do that. We're just going to add in our mirror image, so forget about that. Let's just jump right to graphing. Okay, so the graph will look like this. So set up your coordinate system. First thing that I want you guys to plot is the axis of symmetry here. So you're going to draw a vertical line at x equals 2, so go over 1 unit, 2 units, and you're always going to draw that as a dotted line. It's not a real line because it's not actually part of the graph. It's just going to help us guide our graph. Then our next point, so find the axis of symmetry and the vertex. So the vertex is 2, negative 2. So we're going to go down 2 units, so that right there will be our vertex. So it's either going to be the highest point or the lowest point. We'll see once we get everything sketched out. Step 2, find the y-intercept and its reflection. So the y-intercept is the point 0, 2. So we're up 2 units on the y-axis, right there. And then here's the part where we plot its reflection. So its reflection would be over here, mirror imaged on the other side. So this is 2 units away from the axis of symmetry. So we're going to go another 2 units and then plot its mirror image right there. Okay, so that's enough. 3 points. We need 2 points for a line. We need 3 points for a parabola. So we're just going to connect the dots. That's step 3. Connect the points to the smooth curve. So we're going to connect that. So when I say a smooth curve, I want you to make sure that it's rounded at the ends so that it's not a V like an absolute value because they're two very different graphs. And I also want you to make sure that these pieces on the side are a little bit sloped. I see too many that do like this U shape where the lines end up vertical. The lines won't be vertical. They still kind of go out to the sides like this. All right, so that's kind of our intro to graphing.